All right, so we've been working with the same problem, the same displacement function since the beginning of the lesson, and now we're going to kind of bring it all together with the relationship between displacement, velocity, and acceleration. So part A is asking us to find the speed, absolute value of velocity, right, of the particle at t equals 3 seconds, and then figure out whether that means it's speeding up or it's slowing down. Speeding up or slowing down means that we need to actually find the acceleration at 3. We want to find out whether that's going to match the velocity or not. Okay, so if we find the velocity at 3 seconds, this is for part A, the velocity at 3 seconds is equal to 3 squared minus 42 times 3 plus 60. We get that the velocity at 3 seconds is negative 12 meters per second. Okay, which then tells us that the speed, which is the absolute value of velocity, and again, for the greater sake, I'm writing that so that I can show that relationship that I know, is equal to 12 meters per second. Okay, so from there we can also, so we have the velocity, we have the speed. Let's go ahead and find the acceleration at time of 3. Well, the acceleration function is this last one here that we figured out, so that's 12 times 3 minus 42, which we find out is negative 6 meters per second squared. So here we have a velocity that's negative, and we have a acceleration that's negative. And what we found out in the last slide was that when velocity and acceleration have, if velocity and acceleration have the same sign, then the particle is speeding up. Okay, so that tells us that the particle is speeding up because velocity is greater than 0 and acceleration is greater than 0. Okay, so that answers part A. For part B, we want to, it says during the period of time from 0 to 10 seconds, we want to find the intervals where it's speeding up or slowing down. So we have to compare the velocities, the sign of the velocities, to the sign of the accelerations. So what I'm going to do is I'm actually going to bring back the slide from a couple of videos ago. Maybe. There we go. And this is our velocities here. I'm going to actually extend my screen a little bit here so that I have more writing space. So this was when we were figuring out the velocities of all those things, and then we looked at the sign diagram of that. All right, so basically what we found was that for the velocity, okay, this is going to be my velocity sign diagram. This is a motion diagram. I'm making a sign diagram now. So the sign diagram will start with 0 seconds, and it says to end at 10 seconds, right? And we found out that at these values, at 5 and 2, is where my velocity was 0. So I'm going to put my 5 on there is about halfway, right? And my 2 is about a little bit less than halfway there. So what we found out was the velocity at 1 second, so in between 0 and 2, was positive. So we put a nice little positive sign above that section. And then between 2 and 5, or where 3 was, we found out that this section was negative. And then above 5, we found out that the velocity in that case was positive. Okay, but what we need to do is we need to compare that to a sign diagram for acceleration as well. Okay, we don't know these numbers in between yet because we haven't figured out when acceleration equals 0. So that's what we're going to work on right now. So I'm going to take that acceleration function, from up here, and I'm going to have acceleration equals 0, so that's 12t minus 42, so 42 equals 12t. So acceleration is 0 when your time is at 3.5. So I'm going to throw 3.5 on this graph, right about where that hits, so that's 3.5. Okay, what I'm also going to do is I'm going to kind of connect these two sign diagrams because I'm making a comparison of them, and I want to show that 2 is about that spot right there, right? And I want to show that 5 is at about that spot right there. So looking at the sign diagram for acceleration, we have to figure out where acceleration is positive and negative. So I'm going to go back to that acceleration function, and I'm going to put in a value that's somewhere between 0 and 3.5. So let's go ahead and try an acceleration at 2. So when acceleration is at 2, so that's going to give us positive or negative between this spot. That would be 12 times 2 minus 42, so that actually equals negative 18. So that tells us the space in here is negative. And then I want to find out what sign it is in between 3.5 and 10, so we can just grab the number 4. We grab numbers that make it easy on us. So that's 12 times 4 minus 42. So that actually equals a positive 6. And we could put units on that, meters per second squared, meters per second squared. But the main thing we're interested in is the fact that that's a positive area. So our job now is to identify when the particle is speeding up and when it is slowing down. Okay, so I'm going to take this entire thing here, and I'm going to slide it over some, so that I can do some more writing here. Okay. All right. So we slid that over, and I'm going to make a little bit more writing space for myself here. All right. So we're determining when it's speeding up and when it's slowing down. All right. So in between, see, I made those little marks there so that I could see that this was at 2 right there, and that's at 5. So between 0 and 2, this is negative, and that is positive. So between 0 and 2 seconds, we have signs that don't match. So that tells us that it's slowing down. Now, between 2 and 3.5. So we want another little dotted line to take the 3.5 up to the velocity line so we can see where that's hitting. So it takes it up about there, right? Okay, so between 2 and 3.5, we have a negative acceleration and a negative velocity. So that means the signs match, it's speeding up. Okay, and then my next interval is 3.5 to 5. So 3.5 to 5, we have a positive acceleration and a negative velocity, and they don't match, so that means it's slowing down. And my last interval is from 5 to 10, and we have a positive velocity and a positive acceleration. They match, which means that it's speeding up. Now, you could have written the two speeding ups as this interval and this interval, and slowing down with this interval and this interval. I find it helpful to actually do it in the order that the numbers show up on my number line. So that gives you everything you need to know for right now about motion of a line. We've done some sign diagrams. We've done a motion diagram. We've talked about the velocity being positive or negative. We've talked about speed being the absolute value of velocity. Acceleration, if we're talking about average acceleration, it's the slope of the velocity. And if we're talking about instantaneous acceleration, it's the second derivative of displacement or the first derivative of velocity. And we also discovered that if our velocity and our acceleration signs match, the particle is speeding up, and if they don't match, then the particle is slowing down. So see what you can do with the assignment, and then on Thursday you'll have some IB questions to answer as usual.